previous lecture we solved the problems on DC series motor. Now the last models, the problems on DC compound motor. A short shunt DC compound motor drawing a current of 75 amperes at a voltage of at a supply voltage of 225 volts. Calculate back EMF EB with the resistance of the armature and shunt field resistance. Series field resistances are 0.04, 90 ohms, 0.04 ohms, 90 ohms, and 0.02 ohms respectively. Find the back EMF if it is a long shunt connection. So first of all, short shunt connection you should find out. So write the given data for this. Line current is 75 amperes. Supply voltage is 225 volts. Armature resistance is 0.04 ohms. And shunt field winding resistance is 90 ohms. And RSC is 0.02 ohms. So first draw the short shunt connection. Short shunt connection. In a short shunt connection, the series field winding is connected in series with the line. That means supply. This is a shunt field winding, has a resistance of RSH. The shunt field current is ISH. The current drawn from the motor, the current which is flowing through the armature conductor is IA. The current drawn from the motor is line current. So IA is equal to, we have one relationship IL minus ISH, but ISH is equal to V minus IL into RSC divided by RSH. What is V? 225. The line current which is given as 75. The RSC is 0.02 divided by RSH is 90. So by using calci, I am calculating 225 minus 75 into 0.02 divided by 90 will gives 2.48 amperes. So that is the 2.48 amperes. Now IA is equal to 75 minus 2.48. 75 minus 2.48, then I got it as 72.51 amperes. This is about armature current. After that, EB is equal to V minus IARA minus IL into RSC. So the back EMF is developed in the armature. The armature winding has a resistance is RA, and if you are applying KVL to this loop, then you will get this equation. Yes, again the supply voltage is 225, IA is 72.51 into the armature resistance is 0.04, load is line current is what is the line current is 75 amperes. The RSC value is 0.02. So 225 minus 72.51 into 0.04 minus 75 into 0.02. Then the back EMF I got the answer is 220.599 volts. If you go for the long shunt connection, first draw the diagram. The series field winding in series with the armature is the shunt field winding. I am given the same supply voltage, that is 225 volts. The current drawn from the supply is line current flows through armature is Ia, the current flows through shunt field winding is ISH, the field winding resistance is RSH, this is back EMF, and internal resistance of the winding is RA. Then the node potential you can observe, here is V only. Here also 225 volts will be appeared. Ia is equal to IL minus ISH. The IL 75, yes, the line current is 75 or not, yes or no, 75 minus V divided by RSH. 75 minus V is 225 divided by RSH is 90. 75 minus 225 divided by 90 is equal to 72.5 amperes. EB is equal to V minus IA into RA plus RSC. 225 minus IA is 72.5 and the RA is 0.04. RA is 0.04 and RSC is 0.02. So 225 minus of 72.5 into 0.06, and I got the answer is 220.65. There is not a much difference. See here, this is 220.599 if it is a short shunt connection. If it is a long shunt connection, it is the difference only in terms of points only. So these are the problems on compound motor. So thank you guys.